Okay, great. Well, welcome. My name is David Katzel. I'm the BC Seed Security Program Manager for Farm Folk City Folk and work with an awesome team of 4 other people to run a series of programs. I just wanted to start by acknowledging I'm calling in and mostly work on the lands of the Kwantlen, Katzie, and Stolo First Nations. But we're calling in from unceded traditional territories of many First Nations people whose land we reside on what some people now refer to as British Columbia. And since time immemorial, First Nations people have cared and honored and really taken care of the seeds, a lot of the seeds that we work with, and maintain stories attached to those that have sustained them over time. And I would just like us to be appreciative of that and think of these seeds and where they have come from. And like the land, seeds were never seeded or given up. So we are working with genetics that belong to everybody. I'm excited to hear about this session. We're going to hear from Nicholas Wassler from the Creston Seed Bank project, where they evaluated regionally adapted vegetables and seeds. So Nicholas actually lives and works in the traditional territories of the Tanaxa Nation. He holds a Bachelor's of Applied Science in Sustainable Ag from Kwantlen University. He's been the field manager for a number of organic farms, including Linden Lane in the Kootenays and close to home organics in the Fraser Valley. And he spent a large portion of his career working in the environmental nonprofit sector, conducting restoration projects for the Langley Environmental Partners Society, where I was lucky to meet him for the first time many years ago, and with the BC Wildlife Federation. He currently sits on the Central Kootenay Food Policy Council. He's on Organic BC's accreditation board that oversees organic certification in the province. He's the secretary for iPhone North America, and he's a member of the BC Institute of Agrologists. And as the project coordinator for the Creston Community Seed Bank Society, he was conducting seed trials for climate adaptation and strives to share his passion for blurring the line between nature and food production using agricultural practices. So without further ado, I'm gonna pass it over to Nick.
Thanks, David. Yeah, that's a mouthful. So yeah, I'm the coordinator for the Creston Community Seed Bank Society. I'm really excited to be here today. Like David said, we've known each other for quite a while, and I'm really excited to be working with seeds now after doing a lot of different things over the years. So today we're going to kind of talk a little bit about what the Creston Community Seed Bank is, some of the things that we do. And then we're going to talk about the objectives of this climate adaptation project that we've embarked on over this year and kind of what that's going to look like moving forward. Some of the methodologies that we used in our analysis and trying to figure out how to do this. And then some conclusions. I'm going to preface this with, we don't have all of the conclusions yet. We have a lot of data to get through. I have a binder full of data that we recorded this year that we're still inputting and analyzing. So we'll have kind of some of the things that we're seeing. So, but this presentation is going to be more kind of on what we've done, how you could apply some of these concepts. And then we're hoping to have a report available soon with our final analysis and those sorts of things. But I give that as a preface now to manage expectations. Yeah, so what is the Creston Community Seed Bank? We are really fortunate to be able to live, grow, and operate on the traditional and unceded territories of the Ktunaxa Nation in the Creston Valley. And so the Seed Bank has been an officially incorporated society since 2021. It originally got started by Dan and Val McMurray, who were local seed savers, and they amassed a huge amount of seeds. And when Dan passed away, the seed collection was donated in trust to the College of the Rockies in Creston to be managed. And so from 2014 to 2020, the college managed that as a project. And then in 2020, there were some funding constraints and things. And so the seed bank essentially became its own full society. And so the objective is really to grow genetically pure, open pollinated, climate adapted, ecologically grown seeds that will contribute to our regional's food security. So currently, we have over 500 varieties of tomatoes in our seed bank, and then about another 100 varieties of other vegetables. So it's quite a lot of different varieties of seeds to be managing, and which makes it a lot of fun. I'll also say if you have questions, feel free to type them into the chat as we go. I'm very happy to pause and answer that. I think David is probably will hopefully monitor that and interrupt me as we go. Yeah, so what is a seed bank? We're here talking about seed libraries. So why are we called a seed bank and why aren't we called a seed library? So kind of a very general overview of kind of the seed system. There are a couple of main, I guess, forms of seed saving. We kind of have our seed libraries, which is what we're talking about today with this whole event. And generally, I would say seed libraries are very much about the protection and public access to seeds. So ensuring that those seeds are available at a grassroots level that are available for the community to be able to access. And then we also have seed producers, which are looking more at the commercial side of growing seeds. And so Bob in the last presentation was kind of talking about this as well, that the seeds that maybe a seed producer are growing aren't necessarily those really interesting heirlooms. They might be much more common, they're easy to access. And so seed libraries are probably more likely you're going to be able to find more regionally adapted seeds, more interesting varieties that are harder to find commercially. And then seed banks are kind of in the middle. We kind of operate as a genetic vault that needs to be maintained over the years to be grown out to make sure that these varieties are being held for if we lose varieties, so many varieties have been lost. And so that's kind of a main focus of a seed bank is the protection of varieties. That being said, we also really want, as I think Bob said this in the last one, that it's only as good as it's being accessed. And so we want to ensure that our seeds are being used and are being distributed within the community. I also want to preface this. This is a very general overview of some of the parts of the seed system. This doesn't negate, home growers and seed savers, our seed knowledge keepers, indigenous groups that are saving their own seeds. And so this is a very broad overview. Some seed libraries have backup seed banks within them. Some seed banks have seed libraries. Some seed producers are doing a bit of this. So I think there's a really important exchange between all these parts that needs to occur over time. So this is the Creston Community Seed Bank Gardens. So we are very fortunate to be able to operate from the College of the Rockies. We have a great partnership with them. Originally, this was a horticulture program that operated from the Creston campus. It hasn't operated in quite some time. We're very fortunate to be able to rent a greenhouse and garden space to be able to do our grow outs each year, as well as we have a header house at the back of these greenhouses that we have office space and are able to sort and organize and keep our seeds. We also hold a deep freeze with our like long-term storage of seeds, and then a fridge for more short-term storage. And then we also hold a secondary backup at one of our board members' homes in their deep freeze. So we have, if who knows what happens, we have backups in place. So some of the things that we do as the seed bank is we operate, some of the things we do as a society is we operate the seed bank. That can get a bit convoluted. We use the term society and seed bank a little bit interchangeably, but technically the society operates our seed bank. And then we do seedy Saturdays, usually in the late winter, early spring, to distribute seeds to the community just by donation. We try to get as many seeds out into people's hands as possible. We do a large spring plant sale each year. So we fill our greenhouse just full of plants that we sell at a sale for people, which is very popular. We go to the local farmers market and do a sale from the college campus as well. And then we offer workshops for the community to learn more about seed saving. We bring people like David up to help with seed cleaning and doing workshops. The only picture I could find of a workshop was when I wasn't giving the workshop, which is when David was there. So that's that. And then we have a lot of home growers that grow out seeds for us. This is a really important part of our programs because we don't have enough space to grow out even a portion of the varieties that we need to each year. So by having home growers available to grow out seeds for us is a really crucial part. And we work with them to ensure that they're able to grow those seeds out true to that variety. So we'll usually do at least one visit a year out to their gardens to see how things are coming along, if the variety is looking like it should or not, and providing them with any resources that they need. And we act, as a community resource for just general gardening, farming advice, and then especially for seed saving. And we also have done a little bit of work with elementary schools, providing some seed education, as well as doing a Lawns to Garden program where we have helped build gardens in people's homes and kind of provide them the first step. We'll provide them plants for growing out and just learning about gardening, with the hopes to then move them into becoming one of our home growers as they become more used to growing. So some of the objectives of this project, I'll give you a little bit of context. If you've never been to our small little town in the Kootenays, Creston is about an 8 or 9 hour drive east of Vancouver, and about 5 hours west of Calgary. So we're right on the border of the Idaho Panhandle, on the shores of the Kootenay Lake. So we have this beautiful, beautiful, pristine valley bottom that the Kootenay River flows through. It's a very agricultural region. We have orchards and vineyards and grain farms and dairies and vegetable produce and honeybees. Like we are a mecca of agriculture in the region. And we're very fortunate to have one of the longest growing seasons in the province, outside of like the Lower Mainland and Vancouver Island. So you can kind of see, this is a photo I took from the top of one of our local mountains, Thompson Mountain. And so Creston just sits here at the foot of Arrow Mountain here. And then beyond it is our agricultural region with Duck Lake and Kootenay Lake in the distance there. And so these are the Selkirk mountain range, and this mountain, Mount Thompson, is in the Purcell Mountains. And so the Creston itself has a population of about 5,500 people, and the whole kind of valley and along the lake is about a total of 15,000 people. So not huge, but not a tiny amount. I highly recommend, if you're ever passing through, to take a stop, check out the wineries. It's very beautiful here. So this is kind of the context. This has been a long history of agriculture in this region. It's also home to the Creston Valley Wildlife Management Area, which is a wetland of international importance. There's about 300 different bird species that exist in the wetlands down below in the floodplains here. And the Ktunaxa have a long history of using the wetlands as a food source and the lake in this region. So it's a very plentiful region. And so this kind of gives you an idea of our climate in general. So as we start looking at climate change, on here, low carbon would suggest if we make drastic changes right now to slow the rate of climate change and minimize the overall increase in temperature. This is kind of what the prediction is looking at. And then high carbon would be if we continue at the same rate that we currently are. And so you can see just over time, there's going to be some big changes from growing season length increasing, which could be seen as a good thing, but also summer temperatures increasing from an average of 17 up to 22. This last year wasn't too bad, but the year before with the heat dome, we had temperatures well over 40 degrees for quite a long time. And so we need to be looking to the future for how do we grow in this region, because it is so important. So you can kind of see this was taken from the Columbia Basin climate source. They did a profile for Creston Valley. And so the same thing, low carbon, high carbon. If we're looking at, here we go, 2022, we're kind of an average temperature for the year, about 9 degrees. We're looking low, 10 degrees, but at a high carbon increase well over 12 to 13. And so that's an annual average. And so you can see here, we're way down here, again, an increase for our region is going to come. And I just see that Elizabeth's wondering if this information is available for other regions. So this was from the Columbia Basin Trust, which is the watershed of the Columbia River, which is most of the Kootenays. And so they provide a lot of funding for things specific to the Columbia region. I would assume for most areas, there are varying types of predictions and modeling for climate change. I don't necessarily have a source for outside of the Kootenays, but I think there'd be a lot of available sources out there. It'd just be finding them. And then this was a climate modeling that was being done as well for our region. And so currently, Creston Valley sits within the world's only inland temperate rainforest, which encompasses a large portion of the Kootenays. So we're a very unique climate. And so you can see the valley itself down here in Creston is currently considered to be a grand fir, Douglas fir ecosystem. And kind of the scary thing is, regardless of what projected model, there's 3 different types here, depending on what happens with our climate. Regardless, the valley bottom will end up being a grassland steppe. So we're going to start to see some significant changes in our climate, in our growing conditions. And so we need to start planning for that.
Nicholas, sorry, somebody's just wondering in the chat, is that type of climate information available for other regions?
Yeah, so bits and pieces would be. A lot of this was specific through the Columbia Basin Trust funding. I would assume a lot of regions will have this sort of information available. It would be maybe trickier to find it. It's probably some Google searching and finding some good resources out there. But off the top of my head, for other regions, I'm not too sure. Yeah, sorry.
Thanks.
And so with that, we kind of wanted to answer a few questions. Can we identify varieties of food plants that are heat tolerant and then save viable seeds from those plants? What temperatures result in a damage to crops? So at what point do we need to be worried about crops being damaged by significant amounts of heat? And then what sorts of measurements can we take that can help predict heat tolerance in plants? So is there something that we can, measure, something quantitative or even qualitative that we can look at and go, okay, this variety is most likely to be able to tolerate more heat than this variety because of these measurements. So that's kind of our objectives. These are very, very big, broad questions. A lot of people are asking them, trying to figure it out, and they're challenging to answer, especially because we're working with nature, and because we're working outside, we're at the whim of Mother Nature. And so we aren't necessarily able to fully control what we're doing. And yeah, so we wanted to try a few things to try and answer these questions. So first off, we decided to focus on tomatoes and beans. Tomatoes and beans are both easy to grow in our region. They are easy to save the seeds from. We have quite a few varieties already within our seed bank, or there are some other varieties that we think would grow well in our region. So for tomatoes, we picked 8 different varieties to grow out to be able to compare. And we picked 3 pole bean and 3 bush bean types. So we just kind of how our garden is laid out to keep varieties separate. We planted kind of 6 of each variety of tomato in one plot and 6 of each variety in another plot, with some exceptions that we didn't expect. So for this dance export, this was supposed to be a determinate variety, so a bush that would only grow so high. These seeds originally were saved by Dan McMurray back in the day, and we think that they crossed when he grew them out. And so then a few years ago, those seeds were grown out. They were true to type, as they were kind of a hybrid. And then this year when we grew them out, we had essentially the F2 generation. So after growing out a hybrid, you start seeing all kinds of different variability within the plants. So what we ended up in plot A was 3 indeterminate plants and 3 determinate plants. And in plot B, same thing, 1 determinate and 5 indeterminates. So that kind of skewed our results a little bit because we're no longer comparing, 12 plants that are exactly the same. But it was an interesting thing to see, which is why ensuring that you're not crossing, that you're using the proper isolation distances are so important when saving seeds. And then also our prairie fire, we ended up with 2 sun golds mixed in of the 6 plants that we had planted, which we figured out we had started sun golds for something else, and the transplant at some point got mixed up. So we were able to figure that out, but yeah, so that's kind of these varieties that we chose, and we decided just in how the garden is laid out, and having replicates is always good to have. So we had plot A and plot B set up. And so we ended up conducting some soil tests, 1 test for each plot, just to be able to see if there were any significant differences between the soil types, as different things have grown over the years differently on each plot. So we wanted to be able to see, is there anything significant that is different that could potentially impact the plant growth between the 2 plots. That being said, we weren't sure if we were going to have funding for soil tests, so we didn't end up doing the soil tests until after the plants had grown. I would suggest just do them at the beginning of the season. It gives you a bit of a better chance of results of what the plants are actually going to be taking up. And then we purchased a weather station. So this sits kind of just outside of our plots. And so this is taking temperature, humidity, rainfall, dew points, UV index, wind speed, and every hour it's taking a recording of data. We also have a soil moisture meter connected to this. So that's giving us same thing, hourly readings of soil moisture content, so that we can kind of see what the soil moisture has been doing in relation to the change in temperature or rainfall, or whatever amount of things we want to look at, which this is a lot of data. It's very useful, but again, it can be a lot to figure out what are you asking and which of these aspects actually answer those questions for you. So some of the measurements we decided to take. So for tomatoes, we were going to measure the overall height of each plant. So this was measured twice a week from the soil surface just to the highest growing tip of every plant. So that was, fairly standard measurement across all the plants. We also measured internode distance. So an internode is the space in between each branch. So you can kind of see here, we used a caliper, digital caliper, to measure that distance between the two branches. And we used a marker to mark the leader that we were measuring each time. So we were measuring the same internodes all the way up to be able to see a change. And that this is quite time consuming. So we picked 2 plants for each variety for each plot. So essentially 4 plants per variety. And I'll also add, this is very easy to do when the plants are little and this big, but once you get monster plants, it becomes much more of a challenge to kind of get your body in a yoga pose to get through the branches to measure these. I'll also say a digital caliper is probably too precise of an instrument to measure, just because each time, each week you go back, you may not be at the exact same point on the branch as you're measuring. And so this is such a precise tool. The numbers, like this is, 208 millimeters. That's going to show quite a range when in reality, it's not actually that much. So trying to find the right tools can be a challenge. And then we're also looking at total harvest. So all the tomatoes were counted and weighed per plant each week. And then we also counted and weighed the fruit that we had for seed. So we'll get into this a little bit later, but we had flagged and bagged the fruit that we were going to be saving for seed. And then we also want to look at total biomass. So the total weight of the fruit harvested goes into the total biomass created by the plant. So this is all of the plant's weight. So after we had removed all of the tomatoes from the plants at the end of the season, we essentially chopped up the plants, put them into a bin, and got a total weight of the plant. And then one plant per variety per plot, we dug up the roots and weighed that as well to get, it's a lot to dig up roots. So we just did it for one, and we kind of extrapolate across the variety for a total biomass created by that plant. And then beans, we did the overall height. So for pole beans, we measured straight from the ground to kind of the top on 4 poles. And then for the bush beans, we put stakes into the plants and kind of measured to where the height was reaching on those stakes. And those we were also measuring twice a week. And then same idea with the beans, we took a total biomass at the end. This was a bit more of a challenge because beans you want to dry down on the plant. So this was more of a dry weight than a fresh green weight. So this is kind of what we did. So all of our tomatoes were dug holes. We put 1/3 of a cup of Gaia's 444 fertilizer into the bottom that got mixed up into each hole. And then we added cages for each plant, and we staked those cages as well because tomatoes just get really, really, really heavy and often just topple those tomato cages. So even there were a couple of our big plants that still, even with the stakes, by the end of the season, we're pulling those stakes out of the ground, trying to fall down. But yeah, so you really want to have consistent treatment across all of your plants. This was quite a lot of plants. We planted, 12 plants for the 8 varieties. So you end up with quite a few tomatoes. And so we tried to keep pruning to a minimum, just because we wanted to get that total biomass equation. So I'm a very big proponent of using simple tools that you have with you when you're doing really any work in your garden. We want to remove the lower kind of 6 inches of leaves on the plant just to get the leaves off of the ground where they're more likely to get soil particles splashed on them and have disease. These pruners just happen to be about 6 inches, so it's a very quick and easy way of measuring. So if you're able to find easy, simple tools like that, I always highly recommend that. So we use a tomato clip in greenhouses. If you are pruning these into a single liter on a vine, you would often use tomato clips to kind of prune that tomato, or to hold that tomato to the string you're supporting it with. So these are easy to clip and unclip. So we use that to mark the liter we were measuring for the internodes. The plant still got so bushy, we ended up tying flagging tape onto these clips because it was still so hard to see into the plants because they get so big. And then it's really helpful to have 2 people when you're taking measurements, 1 person to be recording and 1 person to take the measurements, especially with internodes, because you're measuring 1 internode and then moving up to the next one. And it's very easy if you were to let go and write something down to lose track of what internode you've just measured. And then I would also recommend train backup people. If you want days off, you want to still be taking consistent measurements on the same days. And so having backup people and resiliency so that they're trained to measure in the same way that you are measuring, so that every measurement is consistent across the time that you're taking measurements, is really important. And yeah, so because we're growing so many tomatoes and so many varieties so close together, we bag our flowers to prevent cross-pollination between the varieties. These are, I think they're called candy bags. You can get them online, little sachets, and they just cinch tight over a flower cluster. The challenge with these is the smaller the bag, the easier it is to get over the flowers. But once all of those flowers have been pollinated, you would need to take those bags off again. And so the smaller the bag, potentially the harder it is to remove that bag. This is also can be tedious. We tried to bag about 3 flower clusters per plant. So you kind of, with the first flowers, you go through and you bag 1 cluster each. You want to do this before the flowers have actually opened to prevent pollination. And then as the plants grow, you'd go through again and again. And so we did a workshop with community members to teach them how to bag flowers, which really helps with labor and getting other people to help you. And then you have to be able to take off the bags again. So you also have to shake these bags so that the pollen actually pollinates the flowers. They're self-pollinating, but they still need wind and movement to spread that pollen. And then before we take the bag off, you see this bag on the right here has been loosened. We flag that cluster with a piece of yarn so that we know when we come back, these plants or these fruit are for saving seed, and then the other fruit are not for saving seed. And you can see if you forget to remove a bag, they get very stuffed. And sometimes you just have to cut the bags off because they're so filled out. And we topped all these plants once it was very clear that they were kind of reaching their max to actually get fruit ripened. Once you've topped the plants, your height measurements are kind of over at that point, which was a bit of a relief because that left time to then start weighing the harvest. Yeah, so that was those. Yeah, and so then we were counting and weighing all the tomatoes off of each plant. So we used, you can kind of see in this picture, these small plastic trays, and we numbered those 1 through 6. So you could have a person pick one variety and they would harvest all the plants for distribution that were not for seed into one container, and all of the fruit that were ready for seed saving into another container, and those were numbered for that plant. And then you could have another person that was weighing and counting and recording that. And so it's numbered to a plant instead of, having containers that aren't labeled and then you don't actually know which plant these fruit correspond to. And you end up with quite a lot of tomatoes when you grow this much. We partner with our local food bank to distribute the produce through. They were very happy to be getting a mass amount of tomatoes each week from us. And then we processed the seeds, so fermented the seeds, cleaned them, dried them, packaged them, weighed them, and that all goes in. That's another thing we're recording, was the total seed weight for all of our plants. And then these are the different varieties that we ended up growing this year. So you can see here, these are the two, the indeterminate and determinate Dansk exports. So one is much bigger than the other one ended up being. And it's quite interesting when you're working so intimately with each plant to see how they develop over time. I think Guido ended up being one of our favorites. This is a Dutch heirloom, and they end up being just massive tomatoes. We entered one in the Creston Fall Fair and it won first place. It ended up being about 2 pounds for one tomato. It took up like the size of a plate. So, you can eat for a week with those tomatoes. And what was really nice was those didn't split. Often with older heirlooms, you can get splitting. So like the Sandal Moldovan is also a big tomato, but it had a lot more splits in its production. And then we also did germination tests for all of our seeds, just to ensure that they have good quality. So our beans, this year was a weird, cold, cool, long, wet spring. Beans need about 60 degrees Fahrenheit or 15 degrees Celsius for the soil to be consistently at in order for germination to occur. Otherwise, the beans tend to rot in the soil. So for our pole beans tend to take a bit longer to germinate. We started them indoors in these fiber pots. So then beans also don't like having their roots played with too much. So instead of pulling these out and putting them in, you can just plant that whole fiber pot directly into the ground. And then it decomposes as the plant grows. You're not touching those roots as much. Again, using simple things is always easy. We came up with this very simple trellis. This is just 8-foot long 2x2s. We drilled a hole through 2 of them. I think it was about 1 foot from the top. And we put a piece of bent wire through there. That's actually off of the tomato cages that were too tall. We had to chop off legs from the tomato cages. And so we reused those just as a pin bent through. And then on the other two legs, we drilled a hole at about 6 inches. And so you open up the one with the lower pin, kind of like scissors. And then the one with the higher pin sits on top of that the other way. And this, we just dug these in 6 inches into the ground and they stood no problem. And then they simply fold up again for next year. Really helpful, easy tool to use, and was really, really strong. We get quite a lot of high winds through this region, so we were a bit worried, but they were solid all year or all growing season. So the pole beans we planted in kind of a semicircle at the base, 5 plants at the base of each pole. So we ended up with 80 plants. We spread about 2 tablespoons of Gaia through this trench. And yeah, that was planting our pole beans. The bush beans we planted 1 inch deep, 3 inches apart. Did 2 rows, each 10 feet long. So 80 plants again. And again, simple tools. This is a Sharpie with a piece of tape 1 inch from the bottom. Poke that in until the tape touches the ground, pop your seed in. And then from the top of the tape to the end of this part of the pen is the 3-inch spacing. So you just use that to mark to your next hole. Very simple, easy tools, but it makes it a lot easier when instead of having to get a ruler or which when we're taking measurements, we're trying to be consistent. And so that was important that they were consistently at the same depth and consistently spaced. In my own garden, I wouldn't worry so much about being so precise, but when you're doing experiments, we want to be consistent. Yeah, so this is our bush beans again. You can see them coming up. We had a big outbreak of grasshoppers that were just very much enjoying our beans. We ended up putting row cover over all of our beans until they were large enough to kind of withstand any grasshopper bites. And so this is kind of an interesting, these are our 3 pole bean varieties, Mr. Tongues on the left, Major Cooks in the middle, and Lazy Wife on the far right. And so by the beginning of August, you can see both Mr. Tongues and Mr. Cooks are kind of towards the tops of the trellises, whereas Lazy Wife is very, very slow. So this, when you have really clear differentiation between varieties, this is really helpful when determining, does that plant do well in our climate? And then by October 7th, so this is again, Mr. Tongues on the left, it had completely dried down, dropped its leaves, was ready for harvest. Major Cooks, you can see the leaves are starting to dry. It's getting close to being ready for harvest. Some of the beans were dried. And then the Lazy Wife variety had almost no leaves, even starting to dry. Bean pods weren't even fully formed yet, which is really interesting because if we actually look at where these beans have come from, it provides a little bit of background for us. So Mr. Tongues was a variety that was brought to the Kootenays over 100 years ago by a Chinese immigrant. And it's been grown in the Kootenays for that time. So it's very well adapted to our growing region. And so you can see it knew that, yep, fall is coming. It's time to dry, be done. The Major Cooks is a 1950s heirloom. We're not exactly sure where it comes from. And so it was, okay for our region. It ended up drying fine in the end. And Lazy Wife It's actually from North Carolina. And so we thought it needs hot temperatures. This will be perfect now that we're changing in our growing climate. But what we found was it's not, we may be getting those hot temperatures, but we're not getting that same season length because of our cool spring in the summer. We were just very fortunate to have kind of a frost-free fall for an unexpectedly long amount of time, well into October before we had our first frost, which is not normal. If there had been a frost, these would not have finished drying down. But so when you are looking at varieties that, oh, this really likes heat, this might be really good, you actually have to also be looking at your heat unit accumulation and how quickly do you get those heat units and how long does that season actually occur for. So we're going to try growing Lazy Wife again next year just to see if maybe in a different growing season, if it will maybe do better. And maybe we have to start it indoors much earlier in the season to give it that little bit of extension. And then because of the fear of frost for the other varieties, except for the Mr. Tongues, we brought them into our greenhouse to let them finish drying, which we also wanted to collect the biomass for them. So we needed to collect them as well, which is why our trellis was actually really helpful because we were just able to pop those 4 legs out of the ground, lay it down on a tarp, and then simply just pull each section of trellis out of the plants, which made it a lot easier to remove the plants. And then we, once the beans were dry, we threw all the plant material into burlap sacks and stomped on the sacks. This kind of just kept all that plant material together and broke open those seed pods. And then threw that through a screen. And then the small chaff, we blew off using an air compressor and ended up with really clean, beautiful seeds for storage. And then we did germination tests again. So we'll get into some conclusions, some bits and pieces. So this is on the left from plot A, all of the tomato height over the season. So you can see the green, this is prairie fire. This is a small determinate bush variety. So you can see it didn't get very tall over the season, but that's what we would expect. But it was very kind of consistent. And then it plateaued once it reached its predetermined height. What is interesting is kind of by mid-July, we start seeing an increase in our temperatures, like higher than maybe we would like to see. And so that's when you kind of start seeing a bit of a plateauing for some of the varieties in their height. So that kind of starts to tell us that maybe this variety is more susceptible to a bit of heat stress. So like this one specifically, this is Ronaldo. So that's a Roma variety, and it very much wasn't really enjoying the heat. It was also very kind of droopy. And so this is where taking those qualitative notes as you're looking at plants is really important that maybe you can't capture in a measurement. And oh, I see Alina is asking, so were you amending and watering the A plots differently than the B plots? So no, we were using the exact same methods in both plots. Because we're more or less, we're comparing the differences between varieties, not necessarily treatments on those varieties. So if we had the ability to climate control one plot, because we're looking at heat, that's where we would be using different treatments. But because these are both grown outdoors, we weren't able to do that. So we're just replicating each one. And so then the internode, so this is, the internode's just from one plant. So this was Guido from plot B, plant 1. And so this is why there's only a couple of these that I have for you, because for each plant that had its internodes measured, there's a chart like this and other charts. And so there's a lot that we have going. And so this is showing max and min temperatures over the season. So you can see here, middle of July, this is when we start getting to about 32 degrees Celsius. And that's when, just kind of what is to be expected, is that the internode is going to grow over time, and that's going to be affected by heat, potentially. And so we would expect that the warmer it gets, the faster your plant grows, until a certain point where it becomes too hot for that plant. And that's when we would expect to see a decline in that internode growth. So overall height, you're never going to see a decrease, right? Because your plant is only going to get bigger. But the amount with each section that is actually growing, we can see a slowing down, which is what we do see here, is as the temperature increased, we saw a decrease in the growth rate of those internodes. So that kind of is interesting. Again, this is one plant. We need to look at the 4 plants from this variety over compared. And then we need to look at variety to variety. And then it'll also be interesting to see how does this relate to the total biomass or the total harvest that occurred. Maybe the internode slowed down, but it still had a significant harvest, or vice versa, that as the internodes decreased, that the amount of harvest decreased as well because of that heat.
So
yeah, so this is, yeah.
Sorry, just to like clarify on that, because there's a question here, like, why did you measure the internode? It sounds like you're not 100% sure why yet. You're going to see how it correlates to everything else, right?
Yeah, exactly.
Okay.
So this was kind of our hypothesis, was potentially the internode will show some correlation, and the hope would then be that moving forward, maybe all we need to measure is internodes, and that will be able to predict if this plant will be heat tolerant or not. So that's, we're doing a couple of things with this experiment, is seeing which measurements are helpful and which measurements aren't. What I will tell you about internodes is it's very tedious. It's very annoying, especially with growing them in a field cage. I think it'd be easier if you were growing a single liter tomato in a greenhouse, where it's much easier to keep track of the liter that you're measuring. So it's, yeah, kind of picking and choosing what is helpful or not. And so what we found with these internodes is that when a bud forms on the growing shoot above an internode, that internode kind of slows in its growth. So you're usually getting more top growth as your plant gets bigger. The bottom of your plant slows down in how much it's growing over time versus compared to the top of the plant. So really, you probably only need to be measuring your top internodes. And yeah, it's kind of top 4 or 5 internodes will tell you the most over time. The plants grow the most vigorously during your optimum growing temperatures, which is about 13 degrees to 29 degrees Celsius. But once that temperature starts getting over 32 degrees, that's where we see that internode length declining. So that potentially, depending on how this correlates with some of our other data, maybe in moving forward, if we were to try this again, we wait until we see temperatures getting close to the high 20s, then maybe we start measuring the top 4 or 5 internodes, and we track those as we approach 32 degrees. And we might be able to see maybe if the internodes decrease in growth by this much percentage, that would signify this plant won't do well in heat. But if it's maybe a decreases by a lesser percentage, this plant will be better adapted for heat tolerance. Potentially is a hypothesis. We're gonna see, maybe we can answer that this year, maybe not, might be something to try next year to compare. Another thought is the peak temperatures tend to only last 3 to 5 hours during the day. And so pollination is occurring generally in the morning. So your fruit set does continue. But again, this is if you're pollinating by shaking the plants and things like that, that can be different. But I would say generally, this wasn't necessarily something we saw this year because we weren't getting super, super hot temperatures. But often with tomatoes especially, you'll note that at a certain point, flowers tend to abort at a certain heat temperature. But we didn't necessarily see that. We weren't necessarily getting those sorts of temperatures. And then we didn't actually see any relationship between the internode length and the average daily solar radiation. So cloud cover didn't seem to interfere in the growth at this time. And Don has a question here. How many generations do you think it will take to show local climate adaptation? Isn't that what we all want to know? David, do you have any thoughts on? Yeah, it's like.
I guess if you can tell us how long and how the climate will keep changing, then we'll be able to answer that question probably.
Yeah, that's the only thing that's common now is that nothing is common, like the way our climates are changing. I mean, if we look at the bean example, the Mr. Tongues is clearly well adapted for our growing region. As our climate changes, maybe it won't be as well adapted anymore, but that's been in the Kootenays for 100 years. So that's probably quite a few generations of that variety being grown here. I would hope that they adapt quicker than 100 years, because otherwise the rate that our climate is changing, if it takes you 100 years, we're always going to be behind. Yeah, so a few takeaways if you're wanting to do some of these sorts of projects yourself, if you are maybe a seed library that's wanting to do some of your own grow outs, or maybe have some of your experienced growers grow out seeds for you and kind of look at some things. Really spend a lot of time planning and deciding what you're going to measure and why you're measuring it. I think for the headaches for us that internodes took, if we could go back in time, we probably wouldn't have measured them. But that being said, we now know that that is a big headache, and we've done that so you don't have to go forward and learn that for yourself. And so you really want to have you don't want to end up with my binder of data. I don't want that, wish that on any of you, because it's a lot of work to analyze it. So pick a couple of things that are easy to record, that gives you useful data. Like, you can take every measurement in the world, but if you aren't actually able to use it, there's no point in taking that measurement. Be consistent across your trials and replicate them. So that might mean replicate over years or in different growing conditions. Maybe that's like us with plot A and plot B within the same kind of growing area, or it might be grower A and grower B that live in, a couple kilometers away from each other. The more replicates we get, the more helpful our data is. And you want to be consistent across those. If you are, maybe you do want to look at water usage. We didn't. We were consistent with our watering across all of our plants. But maybe that could be something in the future. Maybe we have one plot that gets a lot of water and another plot that gets less water. And that maybe we'll see changes in blossom end rot, which often relates to calcium flow through water in the plant. But maybe we would get some more interesting heat data with that. And then maintain, enter your data as you go. So you don't end up like me in the winter with lots to enter all at once. If you can, take it in bite-sized pieces. And then, stick to your plan, know what you're measuring, why you're measuring it, and how you're going to analyze it. You don't want to get to the end of the season, have all this data, and go, okay, how are we going to put this into Excel that it's useful? What kind of charts do we want to use? Keep it simple. Make it useful. We don't want this to be, a PhD thesis that is published but just sits, in a library somewhere on a shelf that never gets looked at. We want this to be useful for people. So that's for us. In how we've done this, I would never want to submit this for, a PhD thesis. This wasn't the accuracy necessarily. We want this to be useful for the average person, like the citizen science. Citizen seed trials is a great example of a program that is using, the average person and actually impacts growers. So then at the end of your season, review what you've measured, why you've measured it. And then next year, we're going to either grow the same plants, or we're going to use different plants and take the same measurements, or we're not going to do any of those measurements because they weren't actually helpful for us. And so over this season, we distributed over 1,775 pounds of fruit, food through our local food bank to our community. That was a lot of tomatoes. At the end of the season, we were worried about the potential of frost, and so we were able to partner with a local organization called Harvest Share, which goes around and essentially gleans produce from places where it wouldn't necessarily get picked. So they were great to get a bunch of volunteers out and divide up the remaining produce. And that was one of the original pictures we had of all the tomatoes lying in boxes all over the ground. We had a box for every plant because we still had to count and measure and weigh all of those tomatoes. And so it was a little bit chaotic, but we got it all figured out and weighed and counted. And it was a very productive, great day that a lot of hands made for light work. I can tell you it takes a while to go through that many plants by yourself, harvesting a few, counting them, weighing them, writing it down, going on to the next plant. And we ended up saving about 25 kilos of seeds this year for our seed bank. About 19 of that was beans. Our beans were very productive this year, which we're really excited about. And then that's a lot of tomato seeds, quite a lot from this research project, but then we have a lot of home growers that were growing out other varieties that we didn't grow for our research projects. And then while we're running this project with the tomatoes and beans, we're also growing all kinds of other things that need to be grown out for our seed bank. So beets and corn and chickpeas and peas and orac and a bunch of other fun things. Yeah, I think that's kind of more or less what we have to talk about. Say thanks to some of our funders, and David at Farm Folk City Folk has been super helpful and a great resource, especially bringing the seed cleaning equipment out, which saved us a lot of time cleaning seeds. We're hoping to have a finished report by the end of this year in December. That's our goal because funders need that. And we want to make that available to the public to be able to glean bits and pieces from that. So watch this space. Feel free to email me to be on a list to receive that. We'll also be probably putting it on our website and social media when that becomes available. We have lots of resources on our website as well. And we also want to really thank all of our volunteers and our board, and especially our amazing Pat Hewitt, who has been kind of our fearless leader for the seed bank and has taught me so much, and continues to be a great resource for our community and for the seed community. Yeah, questions, thoughts?
That's great.
There's a lot.
Thanks so much, Nick. I've known what these guys have been doing sort of throughout the season. I haven't. It's really amazing to hear all the data you gathered. I had the exact same question about internodes. I'm really curious to see, what that turns out. And I know it sounds like it was a big pain to gather that data, but you never know. Maybe that's really relevant data. And so, yeah, there's a question in the chat here. Somebody's wondering if they can get some of your seed varieties to grow up in the New Denver area. Oh, yeah, you're close. Well, relatively close. It's the Kootenays. Yeah, definitely. Like we do CD Saturdays, usually February and March, and then a plant sale usually in May. But you're local, shoot me an email, and we can figure out getting you some seeds because yeah, we have all kinds of great seeds. I just become a member. I just put the Creston Community Seed Bank link in the chat there. If anybody wants to check them out, yeah, you can contact them that way. I was curious, Nick, if there was, because you were saving and measuring, weighing the seeds of the different varieties. I'm curious about the volume of seeds, like if there was a big difference from one variety to another. As a seed grower, as a seed saver, you often think about the different characteristics of the plant that you like to save. And as somebody who grows and sells seeds, a plant that produces a lot of seeds is very desirable. Keeping in mind, like if you're trying to grow a paste tomato, you don't want a lot of seeds in it. So yeah, I was just curious if you noticed a big difference between the different varieties. Yeah, it was fascinating seeing those differences. And that is some really helpful data that comes out of this. It doesn't necessarily tell us about heat tolerance, but it does tell us
yeah, in future, if we grow these plants out, if we only need this many seeds, we probably only need to grow out this many plants. We found Tiger Tom is a saladette tomato about this big, and prolific amount of seeds, like just insane. The unfortunate thing is it's a really bland, boring tomato that doesn't taste great. And whereas, yeah, our Roma had very few seeds, which is great for aroma, but in terms of saving seeds from that, we'd be needing to plant out a lot to actually get enough to be saving. And then, yeah, some of our really big tomatoes, like that, the Guido and the Sandil Moldovan, not so many seeds. They had lots of, little pockets within the flesh with small amounts of seeds, whereas like the Tiger Tom and the red tomato of Montelari, they had just very large pockets within that were just full of seeds. Yeah, so it's very interesting seeing the differences.
There's a question here just about, can you use candy bags on other plants like peppers?
Yeah, so we usually use, have used bigger ones. You can get different sizes online. Sometimes you put it over like half of the plant or all of the plant, and that's a lot easier than trying to put them over individual flowers. I think Bob was kind of talking about that a little bit too, of like kind of hand pollination and those sorts of things, just to keep, but you still want to do that for multiple plants to ensure your population sizes and that you're mixing those seeds to have good genetics in there.
Yeah.
You want to make sure to shake the bags if you do put them on. That was something we noticed. If there were flowers that had aborted, it was more likely we weren't shaking the bags enough to mix the pollen amongst the flowers than heat or something like that.
I'll also just add to that, and maybe it's obvious, but the bagging flowers only works for flowers that pollinate themselves, unless you want to try to throw a couple insects into each bag, and B, plants that don't suffer inbreeding depression from, some plants really need to cross with the population more than others. So yeah, peppers, tomatoes would work. You could probably bag beans if you really were worried about them crossing, but something like anything in the Brassica family is much more outcrossing. Yeah,
and I would add, when you reuse the bags, don't put it onto another variety because that pollen may still be in that bag. So once our bag is used, either it goes back on the same plant or the same variety, or it gets washed and then reused, because you don't want to mix and end up actually crossing when it shouldn't have been crossed.
And there's a question here. So are there no concerns about the beans crossing? How far apart were your bean plants?
So they were at the extreme sides of our gardens. We were hitting 6-meter isolation distances, which is generally kind of the commercial rate for isolation. That was a bit of a challenge. That maxed out our garden space. This is also something, if you're planning these sorts of things out, is plan your garden before planning how many varieties, and that you have the actual space and how you're going to isolate these across your garden space. It's kind of a Tetris game trying to figure that out. And then if you throw in some crop rotation into there too, it can be a bit complicated.
All right. Are there any other questions that people have?
Oh, there's one here. When you hear folks' opinions about taste performance, do you focus less on keeping that variety going? Yes, so that's with all of our home growers, we have evaluation sheets for them to ensure seed quality. So they fill out those forms for us with, how did it grow? What does it look like? What was the taste profile? Did you enjoy growing this? Did you not? Did it grow well? It's a like 2-pager handout. We usually ask them to take a picture of the fruit and or plant so that we can then compare that to our own database to know, yes, this plant grew true to type or not. If there's potential that there's crossing or maybe a label got mixed up with the transplants or something, we will discard those seeds. Or for some types, maybe we'll, if it's a variety that we know is still well available within the world, and people didn't like it, then the seeds we have, we might just give away through CD Saturday, but we won't necessarily keep that in our bank in long-term storage if it's not good for a region or whatnot. Yeah, I hope that answers that. I assume it's 6 meters between where the plant leaves are. I grew up cattle panels on a hoop setup and planted in opposite corners of raised beds with the plants all merged at the top. Lesson learned. Yeah, how the plants grow is going to affect that isolation. So for us, growing on those teepees, you're more or less able to direct that growth upward. And so they're not going to be going horizontally towards each other. And same with like bush beans are only going to, they don't really stray very far. But yeah, you want to consider that for, yeah, especially if you're growing, I don't know, squash, or although squash needs such big distances, but yeah, it can be a challenge. And I would say too, like, if you're saving it for yourself, like 3 meters is probably fine for beans, like as opposed to 6 meters, like that. I know Bob was talking about that in the last one, but like community differences versus commercial isolation distances.
Yeah, the one thing about beans, even if they're grown right beside each other, they will outcross at about 5%, and they're relatively easy to see the next generation, the ones that outcrossed, because you'll see a color difference or some kind of difference in the bean. So again, yeah, it's
yeah.
For your own garden, probably not a big deal. But.
Yeah, beans are great for saving. Like they're so easy. They're so big to deal with. Don't need tweezers for them.
Yeah, this is great. Thanks so much, Nicholas. I think we've come to the end of the questions, unless there's any more. It's really neat, the stuff that you're doing there. And I also just want to point out to people that it's really important that this type of research, this isn't a one-year research project. Like, this is research that happens over time. And it was funny because, 2 years ago, we had this crazy hot summer that started in June. And I think that's probably where the impetus started to like think through this project, to look at our crops and see how heat tolerant they are. And then we had this year, which was completely opposite in the beginning of the season and completely opposite at the end of the season. And again, it's really important that we do this year over year. There's a question about which organizations funded the research. I think Nick shared it in one of the last slides.
Yeah, so the Columbia Basin Trust was a major funder. So they operate within the Columbia Basin, within the Kootenays, and offer a lot of funding for programs. And then that was kind of distributed through the Creston Valley Community Foundation, through Farm Folk City Folk. We all kind of work together for that funding. And then also CIP, which is, oh no, what is it? It's a CIP grant. I'm sure you can find it online if you're to look that up. And then College of the Rockies is a great partner for us. We pay a very nominal fee to rent the space from them, and they're great at providing an incredible facility that we greatly appreciate. We also always appreciate donations, and like any nonprofit, that's kind of, you know, where we're at, is trying to figure out how do we continue to sustain this and find funding to keep doing this work, right? And yeah.
Yeah, so again, thanks so much. There is a link in the chat there. We just want to mention to anybody, if you're interested in running your own little trial in the backyard, we run a program called the Citizen Seed Trial, which next year we are focusing on early season crops because we're trying to help facilitate this in schools. So we've chosen crops that could be planted and harvested before the end of the school year. So certainly if you're a teacher out there and you work with kids in a garden, it would be great to join, and you're welcome to join in your backyards. And Jillian just added that to the chat. And then the last link I'd like to add, hopefully you'll all click on it. Oh, we added twice, so you have twice the chance of clicking on it. Feedback about the sessions that we're putting on and workshops like this is really valuable to us. It's hard to know if we should keep doing this if we don't hear from you. So, and it also helps us be able to report to funders and let them know. It helps us adapt in the future and come up with other ways of doing these things. So it'll be great to get your feedback. I'll just mention too that you have till at some point this evening to finish watching, if you haven't yet, the Seeds of Vandana Shiva, and that our next workshops are starting next weekend. On Saturday, we have two sort of slightly more advanced seed saving workshops, one on the Brassica genera and family, and one on biennials. That's Saturday. And then on Sunday, look for in-person seed saving workshops in your region. I believe we have some in Squamish, in Lillooet, in Creston, and a couple other places. You should have a link in your email to find those. And then join us from 12 to 1 on the Sunday for general Q&A. We'll try to answer as many seed saving questions as we can. We have 3 amazing seed experts on the panel, and we'd love to see you then. So thanks everybody for joining.
Yeah, thank you, David, for organizing all this and your team. It's great.
Great. Take care, everybody. Thanks so much.